Hi, I'm Scott Denholm, and I'm here with my poster which is on investigating the mechanisms for resistance to Gyrodactylus salaris infections in Atlantic salmon. So Gyrodactylus salaris is a freshwater ectopite. It's an ectoparasite of Atlantic salmon. The Atlantic strain of Atlantic salmon shows no resistance to the parasite and is able to go to epidemic levels and quickly kill off the host population. In contrast, the Baltic strain of Atlantic salmon, here in blue, does show some form of resistance and the parasite is unable to persist. The aim of this study is to use mathematical methods to investigate the differences in the G. salaris life cycle that could cause the differences in parasite population numbers on both strains of Atlantic salmon. So what we've done was parameterised a Leslie matrix model with data found in the literature, in which we want to look at the kind of mechanisms that could explain the Baltic salmon's acquired resistance. The first thing we noticed is that in Baltic salmon, the firstborn parasite is born half a day later than those parasites that are infecting Norwegian stocks, Atlantic stocks. So what we done was we delayed the first parasite birth by 0.5 days, and comparing this with the baseline simulation, what we end up with is around about a 50% decrease in parasite population numbers. And if we go on to continue that and delay the first birth by one whole day, we get a 75% reduction is seen. We next moved on to look at the total number of parasite births. So parasites on the Baltic strain only gave birth to 2 parasites, 2 offspring, whereas parasites on the Atlantic strain give birth to 4 offspring. However, once again, comparing the results we got with the same model, we see that reducing the number of parasites to 2 on the Atlantic actually has very little effect on the parasite population, and it continued to increase. The final mechanism that we looked at was increased parasite death rate. So on the Baltic salmon, the parasite death rate is much lower. So what we've done was, on parasites on the Atlantic salmon, we reduced their survival rate, and this is the kind of results we've got here. So as can be seen, parasites on both Atlantic strains are now in decline, however at a much slower rate than those parasites that are on the Baltic strain. So to conclude, our most surprising result was that delaying the firstborn parasite actually had a large decrease in parasite numbers. We've also confirmed that a reduced number of parasites isn't the reason for the Baltic salmon's acquired resistance, and more intuitively we concluded that an decrease in survival rate actually has the biggest effect on the parasite.